Okay, Eva, can you hear me now? Okay.
Yes, I'm here.
Okay. Last time we discussed the OSI model topic, and in OSI model topic, we discussed day one, day two, and day three topic. Can you please go through this video? Last session video. Hold on. Go to live section. Okay. Last time we done day one, day two, and day three. In day three, we discussed transport layer. Yes or no? In transport layer, we discussed the protocol information. What is the meaning of TCP, UDP, and TCP features we discussed? Okay. Now, after transport layer, we reach on which one layer? Next layer is network layer, a third number layer. Third layer name is network layer. So why we use network layer in network? It will be responsible to add logical address with the help of this addresses data transfer specific source to destination. Okay. Now one more thing. In this layer, data also add IP header. Which one header, dear? IP header. One more thing. In this layer, also help to transfer data via which one part, dear? A best path. So in network layer, we are getting three features to need to discuss. What is the meaning of logical address, IP header, and why we use best path, and which scenario we get a best path mechanism feature. Now, one more thing we need to remember. If you're having a PC, for example, if you're having PC, laptop, okay. So this PC having how many types of address? Types of address. We are getting a two types of address. First is my logical and other is my physical. What is the difference in between logical or physical address? So logical we discuss right now, physical we discuss in next layer. Logical means it's a IP address. IP address means Internet Protocol address. Okay, one more thing. This IP address we are getting two types, version 4 and version 6. Right now, we need to discuss only version 4. We discuss separate part for version 6. Okay, now IPv4. IPv4 means Internet Protocol version 4. It's called numerical address. One more thing. It's provided by INA. It's an organization, Internet Assigned Number of Authority. Now one more thing. IPv4 address size 4 byte, or you can say how many bits? 32 bits. In a 1 byte, 8 bits available. Now one more thing. IPv4 address unlimited. IPv4 address types also available. So we are getting three types of address. One is my private, other is public, and last is which one? A reserve. So this type of address available. For example, this one is your address 10.7.5.9. This one is your IPv4 address. But in this address, we need to discuss one thing. IPv4 address. We are getting octet. Which one is my octet? This one is first octet, second octet, third octet, and which one? Fourth octet. So IPv4 address total 4 octet available. One more thing for IPv4 address. Each octet separated by a dot. Clear? Now one more thing. Single octet size is 8-bit. So 4 octet size, how many? 32 bits. Now one more thing. IPv4, if we are saying 1 octet. So 1 octet is 8-bit, and if you are putting a formula, a 2 power 8. So in single box, we are getting some values 256, but in IPv4, 1 octet range is 0 to how many? 255. So in this first octet, and second octet, third octet, fourth octet, which value we can put? 0 to 255. One more thing. IPv4 divided into classes. So which type of classes we are getting? Write down the class name, and this side we need to put a range. Now we are getting class A, class B, class C, class D, and class is A. Class A address starting from 0 till go to 127. Class B address can be start from 128 till go to 191. Class C start from 192 until sign 223. Class D 224 to 239, and class E 240 to 255. But class A, class B, and class C we are using in network. Class D is reserved. Class E also reserved. This class reserved for multicasting purpose. If you're watching a streaming, so some servers available and all users receiving same video. That means we are using multicasting concept in streaming also. Now reserve, this address reserved for a research purpose only. If you are getting a new technology, so we are using class E. But class A, class B, and class C normally we are using. Now one more thing, remember for classes, one more thing, reserve address information. From class A, 0. This address never assign end devices. End devices means PC, laptop, printer, IP phones, camera. This address used by DHCP process and default routing concept. Clear? Now one more thing. 127. This address reserved for NIC card testing. NIC card means your LAN adapter, Wi-Fi adapter, you can test. So valid range we are getting in class A is only 1 to 126. Class B 128 to 191, class C 192 to 223. If someone asking, sir, how to identify which class of address in use on device. So for example, address is 11.10.5.10. So how to identify? Always check first octet values. So in first octet, which one value we are getting here? 11. Can you please verify in class A, range start from 1 to 126. So that means this one is my class A address. If I am asking 129.10.1.1. So this one address, which class dear? 129 means, can you please verify which class? Class A, class B, class C. Which class address we are using? So 129 available in my class B. So only check first octet. So this one is class B. If someone asking 192.224.1.128. So this one is which class address? Again, verify. First octet, no need to go to third, second, fourth. Only first octet. This one is again which class? Class C, because 192 range start from class C. Now, one more thing. So IP address basic function we discussed. Now, main use for network layer. This side we are getting a PC1 and this side we are getting a PC number 2. Both are physically connected or wireless, no worry. Now, PC1 say my IP is 192.168.1.1 and PC2 say my IP is 192.168.1.2. Now, PC1 say we already generated some data with the help of application. Inside my data, I'm using TCP protocol and some port numbers also add source port, destination port. Now, data reach on network layer and PC1 want to send data traffic on PC2. So with this data, we need to add which one header now, dear? Which one header? IP header. So inside IP header, which type of information we add? First clear, this header size 20 bytes. So that means how many bits? 160 bit by default size. Clear? Now one more thing. Inside IP header, we put source IP. We need to put destination IP. And we also add protocol information. Now, we are sending multiple things in IP header, but commonly most important information is source IP, destination IP, and protocol is very important. Now, source is which one? PC1. So PC1 IP is 192.168.1.1. And which one is my destination? PC2, 192.168.1.2. And if someone asking why we use protocol, so this feature help to know which type of protocol on my upper layer. So before network layer, which one is my upper layer? Transport. On transport layer, which type of protocol we are using? TCP. So inside protocol field, we add TCP and this data will be generated. And now after generating this data and after add with your data IP header, we are calling we generate which one information, dear? Packet. Now next thing, if someone asking why we use best path mechanism, we need to discuss the best path also. Best path. Best path means a shortest path to reach destination. One more thing. Data speed fast via best path. That is the reason. For example, if you are having some users some mobile phones, some laptops also using, and each device connected with your modem. Some device physically connected, some device wireless connectivity. Okay, now modem connected with two ISP, ISP1 and ISP2. ISP1 say I'm getting the speed is 100 MB and this link speed is 2 GB. So right now, whenever this users want to send any data traffic for internet, so which one is best path? This 2 GB best path. But how to get modem? 2 GB is my best path. So network engineer apply a routing. Routing means to get best path. This best path, how to get? We can get manually. We can get automatic. So we just need to go to modem and we configure manually the best path is this one. And this one is my backup path. So some routing protocol for automatic learning the best path, we are using some routing protocols. Which type of routing protocols? RAP, EIGRP, OSPF, BGP. This type of protocol we are using to get the best path to reach destination. So this one is your network layer. Easily we cover. Now data reach on next layer. Next layer is data link layer. Why we use data link layer? It will be responsible to add physical address with data in this layer. Also add Ethernet header. One more thing. In this layer, sub layers also available. Sub layers available. Clear? Now, which type of sub layers? Sub layer we are using LLC or second is MAC. Clear? So for MAC we are using some type field also. Type field, you can see. Now, so first we need to discuss the physical address, then second is Ethernet header, and third is my sub layer information. So if you are having a PC, so PC having a types of address. We are getting two types address. First is my logical, second is my physical. So physically we need to discuss. Logical we already cover on network layer. So physical means it's also known as a hardware address. It's also known as a which one address here? MAC address. Okay, what is the meaning of MAC? MAC means media access control. One more thing, MAC. This address available each device unique. One more thing, MAC. This address provided by vendor plus IEEE organization. Okay. One more thing for MAC. This address available in hexadecimal values. If someone asking, so why we use hexadecimal? Hexadecimal means a combination of numerical plus alphabet. Yeah, we are not getting a special character. Now one more thing for Mac. We need to go to next slide. Okay, Mac. This address size 6 byte. How many size? Able. This address, how many size? 6 byte. 6 byte means how many bits? 48 bits.
48 bits.
Yeah, 48. But one more thing you need to remember. 24 bit for vendor and Mac again. In 24 bits, IEEE plus GL and LG bit we are using. Okay. Now, Mac. For example, how to get the Mac? Example 01 0A12 colon 42 E9 colon DAB7. So this one is your address, MAC address. Example. Now one more thing. In Mac, each value size 4-bit. Yeah? And one more thing. In Mac, total value is how many? 12. So 12 multiplied by 4, 48 bits we are getting. Now, one more thing. We are getting some decimal value and then we are getting some hexadecimal as well. Because if we are saying this single value, how to get 0? Because in decimal, start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So hex is also same 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But if you go to next, if you are getting a decimal is 10, so hex is A. 11, then B. 12, then C. 13, then D. 14, then E. And 15, that means F. So one value can be go to 0 to F. Clear? Now one more point. So MAC address is clear. Now we need to go to next process. For example, this one is PC1 connected with your PC2. So right now PC1 say I'm having the MAC address 0 dot 0 A. So this one is PC1 MAC. Which one device MAC? PC1. PC2 also having the MAC. For example, 0 dot 0 B. So this one is which one device MAC dear? PC2. Now, PC1 say I'm already generated some data. With my data, TCP is already at, IP header is already at. Now data want to transmit via data link layer. So now PC1 say whenever we are trying to forward the data via data link layer, so always add which one header dear? Which one header? Ethernet header. Now Ethernet header add which one information? Source MAC, destination MAC, and sometimes we are getting a type field. Okay. Now always clear this Ethernet header, different types. For protocols, different. For data is different. Clear? So this type field depend on your Ethernet header. Right now we are sending data. So in data, we are using type field. If you are using protocol, so we are using LLC field. Which one? LLC field. Okay, give me 1 second. Hold on. Okay, now verify. LLC means it's called logical link control. LLC means logical link LLC means logical link control, and type field is also similar. But why we use this sub layers LLC or type? Because both of this information will define upper layer protocol information. Which one layer information? Upper layer information. So before data link layer, which type of protocol we are using? IPv4 or IPv6? Even which one? We are using IPv4 or IPv6 address before data link layer?
IPv4.
IPv4. So we put IPv4 and source MAC is 0000000.000a and destination MAC is 000.000.000b. And after add this information with your data Ethernet header. So we are calling, we generate which one information on data link layer? Frame.
Yeah.
On network layer, we create packet. Okay, now data reach on next layer. Okay, just go to next slide. And last layer we need to discuss for OSI model. Now lastly, this layer name is
Cisco.
physical layer. Physical layer means it will be responsible to convert human readable data into which one readable, dear? Machine readable. That means 01010. Clear? In this layer, data convert into bits. Okay. One more thing. In this layer, encapsulation. Which one, dear? Encapsulation perform. Which one? Encapsulation. This layer transmit data on wire. Clear? Or sometimes wireless, sometimes fiber links. Okay. Now, first thing we need to discuss, for example, encapsulation. Encapsulation means it's a very simple. If someone asking what is the meaning of encapsulation, encapsulation means how to wrap a data only. So we are getting two types of encapsulation. One is my HDLC and other is ARPA. So why we use HDLC encapsulation and ARPA? HDLC for which one link? Serial link. For ARPA, for which one link? Ethernet link. Okay. Which one? For Ethernet link. Now, so we need to create a small diagram so you can get some idea. So this side PC1, this side PC2, and this one is connected via serial name. This side we are getting PC1, this side we are getting a PC2, and both are connected with Ethernet technology. Now, PC1 say I want to send data, and PC1 already generated the data. So data, inside data we add TCP protocol, layer 4, on layer 3 IP, on layer 2 Ethernet. Clear? But whenever data transmit via serial link, so in Ethernet, after Ethernet header, we add HDLC plus we convert this data, this complete data into 0101. And this data forward on PC2 side. Now same thing. Now PC1 say I want to send data. So data, add TCP, add IP, add Ethernet header. But now data will transmit by Ethernet. So right now encapsulation is ARPA and data will convert this data 0101 and forward to PC1 to PC2 side. Clear? If in front of your device, this device also using serial, so easily encapsulation read. This side, if we are using Ethernet, so easily we can read. Now, one more thing. After OSI model, we need to discuss important point. Right now, in OSI, we are getting application. We are getting presentation. We are getting session. So right now, clear. These three layers we are calling. Which one layer, dear? Upper layer. Software team will work on this because software team will create the application. Yes or no? Now, next layers. We are getting if transport, if we are getting network, if we are getting data link, if we are getting physical. So those layer we are calling which one layer, dear? Lower layer. Now, one more thing, remember one more thing. We are getting PDU. PDU means protocol data unit. This PDU help to get information each layer which type of information add. So right now application will generate data, presentation layer will represent your data, session will provide the connectivity, but actual work start from my transport layer will do which one PDU task? Segmentation task. So we are calling on transport layer which type of PDU available, dear? Segment. On network layer which type of task we done? IP. But after IP add we create packet. So which type of PDU available on network layer? Packet. On data link layer we create frame. So which type of PDU available on data link?
Frame PDU.
Okay. On physical layer, we convert the data into bit. So which type of PDU available on my physical layer?
Bit.
Okay. Now one more topic. One more. We need to discuss about encapsulation task. And which one, dear? Decapsulation. Encapsulation means how to wrap, how to unwrap your data. For example, this side we are getting a Bob and this side we are getting a SIM. Both are connected with wired connection or wireless, no issue. But right now, for example, this Bob person act as an actual client and SIM act as a which one device, dear? Server. Because SIM will provide some web services. For example, HTTP, HTTPS. For example, SAM will provide FTP service also. So SAM are available with some services. Bob will act as a client to access your services. So now, Bob say my IP is 10.0.0.1 and my MAC address is 00A. SAM will say my IP is 10.0.0.10 and my MAC address is 00, which one, dear? B. Yeah. Now, how to encapsulate Bob data? Bob will access first application, and application will help to generate data. Okay, now presentation layer. On presentation layer, for example, Bob will write down your website name. So data will add your text data. text data,
Text
but
data.
into
Yeah, text.
encode data, in encoding. Now, session layer and transport layer work together. Why? Because session layer will create the session with the help of port numbers. Yes or no? For example, Bob say, I want to access HTTP website. Then, so session layer will add with your data source port and destination port. And source port is always random because we are getting the multiple application to access my HTTP service. But destination is 80 because HTTP service port number is 80. On transport layer, we are using person, TCP or UDP, because whenever we are accessing HTTP sites, so we must be get reply or acknowledge message. So that is the reason session or transport work together. And this data will add which one protocol we are using? TCP. Yeah. Now, after transport layer, data reach on next layer. Next layer is after transport network. On network layer with this data, we add IP header, and IP header source IP, destination IP, and we also add one more information. Which one? Protocol
Port.
to know my upper layer. So source IP is 10.0.0.1 and destination is 10.0.0.10. And which type of protocol before network layer we are using on transport? TCP, UDP, or any other?
TCP.
TCP. Done. Now, network layer, this data will hand over data link. And data link say, okay, now I'm trying to add with your data, which type of header? Ethernet and source MAC we add, destination MAC we add, and we add type field because we are sending some data. Now, source MAC is, which one is source MAC? Bob. So 0.0.0.8.
0.0.0.B.
Yeah, before data link layer, which one is my network layer? Which type of protocol we are using on network layer? Verify.
PTU.
On network layer, which type of protocol we are using for communication? IPv4 or IPv6?
IPv4.
So type field will say on my upper layer, I'm using IPv4. Now, this data reach on my next layer. Next layer is physical. On physical layer, this data will add first. Which one header? ARPA. ARPA means Ethernet communication method encapsulation, and data will be 0.10.1.0. Now, this data Bob sent to SAM side. Now SAM say, okay, I'm receiving your data. My first layer is which one? Physical. On physical layer, SAM will say, okay, I'm receiving your data. With your data, you are sending this information. In this information, SAM verify ARPA means on next layer data link, we add which one header? Ethernet. Okay. And now Ethernet header, SAM verify which one information available?
Send and destination.
This information is available on my data link. And now SAM verify which one is your destination 00B. It's a me. Yes or no? And now SAM verify in type field. Which type of protocol we are using on next layer, on network layer?
IPv4.
So SAM say on IPv4 we add some header. Okay. Now SAM verify on network layer which type of information Bob sending? Verify now. Source IP and destination. And SAM verify the destination IP is 10.0.0.10. It's a me. Accepted? Yes or no? Now SAM verify on protocol, which type of protocol we are using on transport layer? On transport layer, which type of protocol? TCP. In IP header, in protocol field, we add TCP. Na? After network, we reach transport. Na? Now.
Okay.
Then go to next layer on session layer. How session will be maintained? With the help of port numbers. So now SAM will say, okay, which type of port number sending the client? So Bob say, okay, I am sending the source port is 1025, destination is 80. Sam will verify, transport and session work together, and now Sam verify. Sam say, on destination port is 80. That means which type of service? Which type of service use 80 number port?
HTTP.
HTTP. That means this client trying to access HTTP service. If this client want to access FTP, so which type of port number will be added in my session layer or transport layer? Which type of destination port?
Port 21.
21, and this one is 443, and this one is 80. Very good. Now, data will reach on now presentation layer and application. This layers also work together, and data will be received. Clear? So this one is my encapsulation mechanism, and right side we are using decapsulation mechanism. This thing is done. Okay. Now OSI is complete. Now next session we'll discuss the IP address class and subnetting topic. Which one? IP address and subnetting topic. Go through this video. We meet again tomorrow, same time.
I did not record, so you have to send it to me.
Yes, you
Thank
can
you.
receive. Bye
Thank
bye.
you.